All right, so here we have a graph that's given to us. And what they're saying is that a leaf it falls from the tree into the swirling wind. The graph at the right shows the vertical distance in feet. So this is a distance graph. We have to understand that first before we even attempt to solve all this problem. They can give you some different types of graph. It could be the velocity graph, an acceleration graph. So I'm going to make this maybe big here. So this is a distance graph. Above the ground, plotted against time. So we have distance over time. According to the graph, in what time interval? So we have to give them two specific times. I'm not going to say, oh, this is happening at t equals 5. That would not be an interval. Right? So I'm picking up a lot of clues from this word problem to answer them. What interval is the speed of the leaf the greatest? So a couple of things that come to my head. Speed does have a connection with velocity. Speed equals the absolute value of velocity. So if I had the velocity information, I can just take the absolute value of that, and I will get my speed. But however, we don't have that. We only have this distance graph. So we're looking for the interval where the speed is the greatest. Right? Now, if I start looking at this distance function here, and I want to get into the mindset of speed, then before I jump into the speed, I have to go through some hurdles here, and first I need to think about what the velocity will look like. And unfortunately, I do know that the derivative of a position graph, which is this distance, it will get me my velocity information that I need. So a derivative graphically is nothing more than tangent lines to this particular graph. So I can pick up points and I can say all of these little slopes here are giving me information about the velocity. The slopes, if the slope here is 1, then that means that the velocity there is a 1. If the slope right here is a 5, that means that the velocity there is a 5. Right? These are straight lines. So by because the problem is rigged, they did it this way so that you can compute slopes. So from here to here, from here, this point to this point, from t equals 1 to t equals 3, I can compute that slope, and the slope will be the same throughout the whole piece of the line. So that means that the velocity from this point to this point, it's equal. Right? In this case, I can use my rise over run scales, and I can say, well, my rise is 5, and my run is 2, so this is 5 over 2, and it's a positive. Right? So the velocity is 5 over 2 from here to here. What's the speed? Well, if the velocity is 5 halves, then I would just take the absolute value of 5 halves, and the speed would be 5 halves. Here, the rise is 10, and the run is 2, from here to here, because the slope there is a 2. And that's a 5, so the velocity is 5. Remember, this is negative. So it will be a negative 5, but I'm interested in the speed, so the absolute value of negative 5 is just 5. So that has a greater speed, that interval there has a greater speed than this one up here. Right? And then so on, you will keep on computing velocities, taking the absolute values of those, and you come up with the speed. Basically, you're just looking for the steepest line, right? If you're looking at the distance line. So in this case, it will be between 3 and 5. So that would be your final answer. They are not asking you to justify this, so you will just kill the question with this answer right there. So very straightforward. Very nice way of testing you on whether you understand what the connection between velocity and speed is coming from a position graph.